Thank you so much. Good morning from Geneva. Thank you for the invitation. So I will, in my presentation, cover a little bit more ground in terms of explaining what actually is geoengineering. And I want to take us on a very short history tour of what I call the history of forgotten alternatives in international climate policy making to explain why we ended up where we are today. I want to briefly highlight some of the key narratives and risks around specific geoengineering technologies. And I want to walk you through the latest climate science, because geoengineering proponents often cite the IPCC. And I want to walk you through what the IPCC actually says. I'll briefly flag some of the restrictive governance and show and explain and share some of the key struggles and resistance campaigns that civil society is involved in when it comes to geoengineering. So that's a lot, and I'll go quickly and look forward to some questions later. So what is geoengineering? And Clive already covered some of that, but just to be clear what I'm talking about, it's a set of technologies to intentionally intervene in and alter the Earth system on a mega scale. The scale is important. So it's there's the technologies to manipulate the climate, to counteract, to treat some of the symptoms of climate change. It's basically a techno fix for climate change. And generally we hear about two different approaches: solar geoengineering and carbon removal, but there are different ways of categorizing geoengineering technologies. Two other sort of angles to look at that I find really important is that there are technologies that intervene in land ecosystems, in the atmosphere or in the oceans, and they differ quite a bit. And when we look at geoengineering, it's very important to distinguish between approaches that are all about engineered technological carbon removal, and they're distinct from natural ecosystem restoration. So that just as a starting point, and to give you a little bit more of an overview, this table shows not all of the approaches, but when a certain way of categorizing them. You see at the top you have solar or atmospheric interventions, you have land-based interventions and marine interventions, and on the left side, you have solar radiation modification technologies that try to modify radiative forcing levels, and that's mostly the type that Clive just spoke about. And then there are carbon dioxide removal or other greenhouse gas removal technologies, and they happen in different ecosystems. What doesn't fully fall into the geoengineering discussion is weather modification. So, for example, cloud seeding, that's something that happens at a much more local scale. So for us in our work, it doesn't fall into the same category. There is a link and a shared research history for some of these approaches, and also carbon capture and storage, or carbon capture utilization and storage, are not per se geoengineering technologies, but they're enabling technologies for a lot of the carbon removal ones. So you see a whole list of technologies. The one I've highlighted here, stratospheric aerosol injection, is the same one that Clive just talked about. But there are many, many more, and I can't actually go into all of them. That wouldn't make any sense. I'll come back to a few of them in a little bit. But what I find really important to understand this current discussion of geoengineering is to look at the history of international climate policy making, and to understand what are the turns we took and what are the turns we didn't take. And so how did we end up where we are today in this discussion? And for me, it's really an increasingly narrow path that we're looking at. So the key turns, just to pick a few that we took, were in 1992 with the UN Framework Convention on Climate Change. We decided to identify the problem as one of emissions of carbon in the atmosphere, something very abstract. We did not decide to define the problem as burning of fossil fuels or extractivism or other root causes of the climate crisis. In 1997, with the Kyoto Protocol, we went another step and decided that we could basically start trade carbon credits, and that the carbon released through industrial processes, burning coal, for example, would be, 1 ton from that would be the same as 1 ton of carbon stored in a tree or in soil, and that those tons of carbon would be fungible. That was a concept that we established, at that time, that put us onto a very narrow path in terms of looking for potential solutions to the crisis. And with the Paris Agreement in 2015, that's the net zero concept. It's not in the Paris Agreement, but it's interpreted, the interpretation emerged from the Paris Agreement. And since then, we've been talking about carbon removal as a concept. And that, again, is a new step in our thinking, in our way of describing the problem, thinking that it's a problem that we can first do harm and then clean up later. That forces us to think about solutions in a certain way. It could have been different, but that's what we decided. And our path became even narrower. We're about to take a next turn and redefine the very metric for the problem that we're talking about, no longer being about carbon, but temperature levels and radiative forcing levels. So in my view, how we define a problem matters greatly in terms of which solutions become imaginable. And at this point, we are, basically almost blind and stumbling through this crisis and no longer in a position to actually imagine all kinds of solutions. And that is highly problematic. So what are the main arguments that proponents of geoengineering approaches bring forward? And I'm hearing them every day. They say that overshooting our temperature targets is unavoidable, and they quote the IPCC for that. They say we need all options on the table, all hands on deck. They say research alone is not deployment. So knowing more, doing more research is always better, and small experiments also outdoors are not a huge problem. They say we need to prepare because there is no risk-free future. So we know climate change is hitting hard, it's going to get worse. We know geoengineering has bad side effects, but we need to take some sort of risk assessment. And actually, we just need to establish the right kind of governance, and then all will be well. And it's actually much cheaper than reducing emissions. So those are some of the main arguments that we're hearing from geoengineering proponents. So this is not what I'm saying, this is what proponents of geoengineering are saying. What are some of the main issues and problems and dangers of geoengineering? And they're real. So betting on overshoot, assuming that we will overshoot our temperature targets, is really delaying the real solutions that are available at scale today. And it's delaying a phase out of fossil fuels. And I'll come back to that when I walk you through the IPCC science. The potential of actually doing large scale carbon removal is unproven and highly uncertain. Again, that's what the IPCC says. Solar geoengineering specifically is speculative, risky. Most of the technologies are basically untestable at scale, like they're untestable in terms of actually testing their impact on the climate, because that scale would equal deployment, and they're also ungovernable, and Clive spoke to that already. Geoengineering clearly does not address the root causes, it only treats some of the symptoms. It harms ecosystems, it undermines livelihoods, it violates human rights and free, prior, informed consent of Indigenous communities. It also comes with massive new resource-consuming infrastructures, and it holds the potential of very strict corporate or military control, and many of the approaches are profit-driven. So these are just some general terms, and we could be going into much greater detail, but I thought I'd just give a few examples. So when it comes to marine geoengineering, this is from a very important study by Lisa Levin and others on the impacts of marine geoengineering on the deep ocean. And as you can see, there are various geoengineering approaches that are discussed here, from cultivating macroalgae at industrial scale at the ocean surface, but also doing what is called artificial upwelling. A lot of approaches that are meant to really increase the carbon uptake in the ocean, but also approaches that make the ocean surface more reflective. All of them alter the ocean chemistry, and they alter the food chain, and most of them are about introducing novel substances into complex ecosystems that we barely understand. So marine biologists are ringing the alarm bells and saying, we do not understand what this is doing. This is a huge risk for the oceans, and the oceans are a main carbon sink. We depend on the ocean for our lives and our livelihoods, and we should not be meddling and using them as, experimental fields for these highly risky, speculative approaches. One particular one I wanted to highlight, because it's not as much discussed, but there's a lot moving in terms of research and outdoor experimentation. It's called ocean alkalinity enhancement. And it's basically the idea that we would increase the carbon uptake in the ocean by spreading a pulverized mineral dust on the ocean. And that alkaline material would basically increase the uptake of ocean because it also alters the chemistry. Doing that at any scale where it would affect the global climate, according to this study I'm citing here, would actually require mining of that material at a scale that would be 4 times larger than the current global coal production. That is the scale we're looking at. This is not a small intervention. If any of these approaches were ever to be used to have an effect on the climate, they would be gigantic and massive. And they would use massive resources and create new extractive infrastructures. Stratospheric aerosol injection, we've talked about this. I really just want to highlight the risk of termination shock, because I think that is the key one. The carbon stays in the atmosphere basically almost forever, for a very long time. Any chemicals that we would spread into the higher atmosphere, the stratosphere, would stay there for a much shorter period of time. So we would basically need to continue to put them there for a very long time, for decades, for hundreds of years, possibly longer. And we would need a governance system to sustain that. And if we were ever to stop doing that, then we'd have a sudden temperature rise based on the level of carbon in the atmosphere. That is not anything that we can govern in any way. So that basically rules this out as an approach to even, further think about research and develop towards. And then there's tons of, so-called carbon removal technologies I've picked here. So 1.5 is one of the major companies that is investing in so-called direct air capture, which is the idea that we can chemically filter carbon from ambient air and then store it underground, through CCS. Yeah. They're currently developing some major projects in the Permian Basin in the US, so the biggest carbon bomb in the world. Their business model has nothing to do with climate, really. What they want to do is use the carbon that they filter from the air to pump it in the ground to get more oil out. It's called enhanced oil recovery. They want to sell carbon offsets, and they want to create, petrochemical products like fuels. It is not a climate solution. It is a business model, and it seriously delays climate action and benefits the fossil fuel industry. And that is what direct air capture really is at the moment. But our governments are turbocharging it with subsidies. The IPCC. So the working group 2 in the last assessment cycle that looks at the impacts on the climate really highlights that we cannot afford to cross the threshold of 1.5, because any impacts, would be potentially irreversible. So that the concept of irreversible impacts is really important. And that we cannot rely on unproven technologies and large-scale carbon dioxide removal or solar radiation modification, because they may prove ineffective, and that would just create further disaster. The working group 3 that looks at mitigation goes further. It also talks about carbon capture and storage being extremely costly, very inefficient, basically not available in the crucial decade ahead. So nothing that governments can count on. That's not a message that governments want to hear right now, but that is what the IPCC says. And it also talks a lot about the technological risks and speculative nature of large-scale carbon dioxide removal. And the summary for policymakers that really summarizes all of the IPCC science of the last, 8 years, basically, also says that proven and readily available solutions exist, and they can be, rolled out at scale right now. But what we're really seeing, that's not from the IPCC, that's our interpretation, is that puts the fossil economy at risk. So they're fighting back, and they're putting out carbon capture and storage and carbon dioxide removal as their line of defense, and they cover up for further expansion of their polluting businesses. The IPCC also makes it clear it is still possible to limit global warming to 1.5. The risk of, a very, approaching that target, that limit is very real, but also makes it clear that every fraction of a degree matters, and that it's better to fail at 1.5 and stop soon after than to basically blow up the carbon budget and succeed at 2 degrees. There's two international, so many believe that there is no governance of geoengineering. We're actually not in a legal vacuum. So the two things I want to highlight that are really important for our work as civil society on this is that the Convention on Biological Diversity under the UN first took a decision on ocean fertilization, one particular technology, but then in 2010, really made a landmarked consensus decision that basically amounts to a de facto global moratorium on all geoengineering that would affect biodiversity, so basically all. And they've reconfirmed that decision several times. And the London Protocol, the London Convention under the International Maritime Organization has also worked to really govern marine-based geoengineering. They've done thorough assessments, and they've basically created a decision where they've put ocean fertilization as a technology in an annex of marine geoengineering technologies that are banned. Some of that has not entered into force, but legal scholars agree that this basically amounts to an effective ban on ocean fertilization, even though we see that, still that technology being proposed over and over again in many fora. And the London Convention, that's important, the London Protocol, they're at this point looking at also regulating some of the key emerging marine geoengineering technologies on ocean alkalinity enhancement, macroalgae cultivation, artificial upwelling, and also marine cloud brightening and reflective materials. Marine cloud brightening is the one that also Clive talked about. I will finish with just speaking very briefly about what civil society is doing. So as the Center for International Environmental Law, we're part of the so-called Hands of Mother Earth Alliance, the Home Alliance that works against geoengineering. I sit on the steering committee of Home, and Home, basically, it was launched in 2010, but then relaunched in 2018 with much more force and participation, with a big manifesto signed by over 200 organizations around the world, really resisting all geoengineering. And it's gaining a lot of traction and support right now. And Home, by no means, is not the only civil society alliance or network resisting and opposing geoengineering. Also, the largest civil society network on climate in the world, the Climate Action Network International, has a specific position against solar radiation modification, and also rejects CCS and direct air capture as climate solutions. There are many, many more groups, indigenous groups and others, that are mobilizing against geoengineering at this point across the board. Some of the, just to show what some of that resistance looks like. So there was a proposed flight by one of the main stratospheric aerosol injection research projects. They called SCOPAX, housed by Harvard University. They wanted to test their equipment to bring the chemicals into the stratosphere, and they wanted to launch a flight from a space station in Sweden. And then the Indigenous Sami Council in Sweden led an international resistance effort, and not only lobbied and successfully managed to get this flight cancelled, but also put out a petition with leading indigenous groups from around the world to call to shut down the entire SCOPAX research project. They have not received a response from Harvard on this one. Indigenous groups also protested against the so-called Arctic Ice Project, that is, putting reflective materials, silica beads on ice. This is a protest they did at one of the fundraising events of the Arctic Ice Project. The founder of Arctic Ice has since moved on and has created a new project called the Bright Ice Initiative, and is planning to test her technology on glacier ice in India. At this point, they've moved away from, because they couldn't get any permits to actually do the testing on sea ice in the Arctic, and this was partly due to some of the civil society and indigenous organizing. And finally, closer to home in Europe, a Canadian firm, Planetary Tech, are doing want to test ocean alkalinity enhancement. So the technology I explained on a beach in Cornwall in the UK, and local groups are organizing against this, and they're mobilizing the environmental protection agencies in the UK, local governments, and are really staging protests because they're very concerned about this particular testing in the UK. This is my contact if you want to know more, and there are also many resources to share on all of this. Thank you so much.